Hi, my name is Bill Bofiesel with Granger Construction. I was a project manager involved with this mass timber project. Obviously, this is new to everybody in the industry over here in the United States, so to make sure that we met the milestones for this project and for our design team and stakeholders, we met multiple times, either virtually or in person, at least 2 to 3 times a week, to make sure that we talk through the important engineering items that were involved with this project. Some of those engineering items that we had to talk through were right sizing the members. So each manufacturer of mass timber has their own sizes, so we had to get through that evaluation first before we could move into vibration design. Once we got through vibration design, we got through the delegated connection design of the project. And so at that point, we were able to bundle up the floors and submit the calculations to the structural engineer of record, and then move into fabrication. But what allowed us to get into fabrication was to finalize that geometry for each building and transfer that information to the BIM model for MEP trades to interface with as we went through the BIM model and clash detection for the facility. So as we completed the engineering process, we needed to transition to fabrication of the mass timber. Some of the elements there are not typical throughout the process as you would have for steel construction. We had to take the geometry that was approved and transfer that to a programming software so they could CNC the timbers. Some people might ask, why are they CNCing the timbers? It's because the precision that they use is up to 1/16 for fabrication. So at the same time that they're programming, they're gluing all the timber members, and then once the timber members are glued and programming is complete, they're able to begin the fabrication process. And there's 2 steps to that. One step is for the glue lam columns and beams for the floor, and then there's the CLT. Now those 2 processes are done in different plants, so those can happen concurrently. Once we're able to get through the process of fabrication, then we need to worry about procurement and delivery to the job site. And that process for our job was across international borders, so we had to deal with customs. To make sure that we had just-in-time deliveries, we had to deal with the installer as well to make sure that their time commitments were reliable as we had just-in-time deliveries to the job site. So that involved having daily communications with the manufacturer who's fabricating it and with the installer on site who is erecting the facility, and making sure that we take into account weather delays or potential delays that we have with design. And through that process, we were able to maintain our schedule and hit our milestones along the way and get ready for our MEP trades to interface and bring in overhead utilities and rough in. As mentioned earlier, once we were able to finalize the geometry and get that into the BIM model, we were able to turn that over to our MEP trades for coordination and clash detection. So in a typical building, you might not worry about what the anchors look like in the deck, or coming through the floor vertically with sanitary, any other utilities that come up vertically like electrical or duct shafts. Some of those things are just second nature when you're erecting a building that's made out of typical structural steel or cast-in-place concrete. But here with mass timber, we needed to consider those elements with our design team members and make sure that we coordinate correctly with them. Some examples of that were coring through the CLT for sanitary or electrical feeders. There's spacing requirements when you cut through the CLT that we had to take in consideration, and depending on the span of the CLT, whether we're parallel or perpendicular to it, would change those rules. Some other elements along with the structure of the CLT were the Simpson straps. That tied all the CLT floor panels together, and we had to make sure that our vertical penetrations didn't cut through those straps, or else it would lose integrity structurally for the building. Some other things related to the structure and our MEP BIM coordination were the fact that all of our ceilings were exposed. And so elements like anchoring into the CLT deck from above were very critical in the process of developing this model. Usually you're at a 300 level BIM model for buildings, but we had to be in the 400 to 500 range and really get granular with the detail of our model to position our anchors into the deck and be able to transfer the information from the model to the field in an accurate way. To be able to transfer the information from the model to the field, we use Trimble to lay out each one of the SAMI anchor positions in the deck.
One of the challenges and that the team faced, and also an opportunity that was presented by mass timber, was to understand how logistically we bring in a new product to the site, how we make that interface with the other trades and the other systems that we're familiar with, and make it a success. So some of the things that we looked at the size of crane. Would it be different if it was timber versus steel versus precast? We looked at site logistics. How much would we have to stage on site? How would we get it in? Our superintendent and our project manager on site worked very closely with our mass timber subcontractor and established seamless flow of materials to the site. Worked closely together with the installing subcontractor right here from locally in Lansing, Chrisman Constructors, and together put together a really great plan to put up the timber in a pretty quick, rapid pace. There was a learning curve for everybody at the beginning of the project, understanding how to receive the materials, install them, protect them, and get their carpenters on site trained to do so. But once the team got through that learning curve, it was really sort of a thing of beauty to watch the installing carpenters do their work and install the timber in an exceptional way. So one of the challenges and the opportunities that implementing mass timber at the STEM site presented was the overall sequencing and planning of the installation and the logistics that come along with that. The STEM site is a fairly tight site located right in the middle of campus, so site logistics and the efficiency of the installation was a critical part of the project plan and a critical part of meeting the overall schedule. So some of the things that we had to think about, both on our side as a construction manager and our mass timber vendor and also the installing contractor right here in Lansing, Chrisman Constructors, is we had to think through things you would normally have to think through for a structural system, like things like crane size, things like site laydown. But other new things we had to think about was, how do we stage panels that are this large? How do we protect the material once it goes in? And how do we keep the weather and the rain off of it and also carry it through 2 Michigan winters, which was a pretty unique challenge and a pretty big concern for this type of material. So some of the things the project team did is we leveraged that collaboration that we started at the beginning. We brought in those trade experts. We work with our crane vendor, who happened to be ourselves. We were able to provide the crane, which provided some value. And then we worked through sealing the mass timber before it showed up on site to protect from weather. We installed wood around the wood to prevent it from damage throughout the building. And then the carpentry team really did an exceptional job of learning a little bit every single day, every single week, and putting some intention into flattening the learning curve and improving their installation processes. And once they got going, it took a little bit of time to learn that process, a little more than any one of us would have expected on a brand new system. But once they got going, those installing tradesmen and women really did an exceptional job putting together the quality project you see behind us.
Okay, so some of you might be thinking, why use mass timber? What are some of the pros and cons? What should I think about when erecting mass timber or using it for my project? Well, some of the things you need to think about are moisture mitigation. So when you're erecting this mass timber and you develop a level or the second floor or third floor, in the case of a rain event, you need to squeegee off the water off the deck. Otherwise, the wood's going to absorb that water, and if you exceed a certain moisture content in that wood, you'll have to stop construction until you get below that value, which usually peaks at about 16 to 18%. The timber comes out with an internal moisture content of about 12%. So you need to watch those and talk to your testing consultant and make sure that we're checking that frequently while you're doing the erection of the timber. Another thing is, as soon as you start building the project and you have the columns positioned and you're going vertical with your structure, you need to think about how you're going to protect those columns. So for this project, you'll see in some of the pictures that we developed a plywood protective layer around the columns so that as we continue on with construction, some of the other trades that are coming behind the structure aren't damaging those columns. So that's another thing you want to think about. As you're erecting the structure itself with the deck and the beams and the columns, there's always a concern about water standing. So you need to take that in consideration when you're developing your estimate and budget for the project, knowing that you're probably going to have to come back and sand and maybe refinish some of the features of this building. And lastly, one of the bigger advantages of this project was we have a 3-inch topping on this deck. And typically with a metal deck and steel structure, you might see some greater deflection in the floor. Whereas here, we probably saw in the span of maybe an 1/8 inch of deflection. So you're able to really tackle a lot of surface area when you're placing your concrete on top of these decks as you continue on with the structure. So there's a lot of advantages with mass timber, speed of erection, continuing up vertically and placing the concrete, not having to worry about deflection as much, and then allowing your MEP trades to begin roughing from the floor below faster than you would typically with some other methods of construction.